In this third part of the video, we're going to wrap up the Bohr model and look at what some of the newer models of the atom look like. Remember that Niels Bohr modified the Rutherford model, constraining electrons to be in certain orbits. Those orbits are known as energy levels because electrons have only certain amounts of energy, the ground state, and then certain allowed excited states. So nucleus, orbits, electrons have to be in the orbits. They can jump from one orbit to another, but they will always jump back down to the ground state. When they do those transitions, they absorb energy to jump from a lower to a higher. They give it back and emit radiation when they go back. All right, so here's the great thing about the Bohr model. It works perfectly for hydrogen. However, it doesn't work for anything else. So it was great for what it did, but it doesn't work for any other element except for hydrogen. So it's not the answer to what atoms are like. So let's look at some more different evidence. The French chemist Louis deBroglie suggested that matter, which we normally think of as being particles, may have wave-like properties. In fact, he came up with an equation to calculate the wavelength of particles. Excuse me. Light, remember, has this wave-particle duality. It acts like waves under certain circumstances and particles under others. And so it turns out that experiments show that electrons also have this property of being like particles in some circumstances and waves in other circumstances. So apparently what's going on in the atom is a whole lot more complicated than simply a nucleus with electrons orbiting around it. These electrons are complex things that are doing things that are maybe a little more complicated than we normally understand. Okay, so then this guy, his name was Schrödinger, and he worked together, and there were actually several people working on this, and this is sometimes known as the Born-Heisenberg-Schrödinger model. He looked at the electrons as being purely mathematical constructs because the physical reality of electrons is a little hard to pin down. And so looking at it mathematically, he came up with a new model for the atom, which we now know as the wave mechanical model, based on the concept that electrons are like waves. And so this is the one that we are accepting today, and we're going to spend time talking about some of the details of. This one came around in the mid-20s, around 1926, and it's the one we're accepting today without too much change. So it's been around for coming up on, 100 years, 90 years or so. So it's stood the test of time so far. Now, if we go back and review all of these other models, pretty much over about 30 years, they were all developed and discarded. So this one has stuck, and it's the one that we're going to now look at in detail as we go forward.